Hello and welcome to another episode of BTech. Today we're going to be talking about aligning our Harbor Freight mini mill to the bed. So this is our table, sometimes I call it the bed. It moves all around under the mill head, which can move up and down. Now, for a lot of things, we want the tool that's coming out of the mill to be perfectly 90-degree perpendicular to the table. Now, the problem with a lot of the Harbor Freight mini mills like mine, or maybe it's a good thing, is the angle is adjustable. Now, as you might expect, this indicator right here is useless. So it'll get you maybe within, 5 degrees, something atrocious. So you're better off just ignoring it until you set your own vertical alignment, and then obviously you can put your own mark in there to be helpful. Now let's talk about a couple of different ways we can do this, starting with relatively cheap and easy ones, then on to more expensive ones that are going to offer more accuracy and precision. So we're going to start out with something very easy, which is a lot of people have a digital level. This is nothing particular special. I'll put a link to the description, which I try to do with almost everything. So we're gonna do here is first we're gonna make sure our bed's all nice and clean, so there's not crud on it, because we do want to make sure we get a really good alignment. We're just gonna get this on here. It doesn't magnetically stick to it. Fire it up. You see it's giving us a 0.3 degree angle. Now then the question becomes, well, what do you align it to up here? So one of the things we could do is we put it around top of the mill head here, 0.55, which means we would have to rotate it to the left to get it into alignment. You can see if we put it on the head itself, probably the most accurate, we're getting about 0.6. So let's try to get this in line, being what this is here. So let's try to get it to 0.25. So it's saying we're about 0.25 degrees off. What we're gonna do is loosen the bulb back here just a little bit. And we're gonna tap with a hammer up here, make real small adjustments hopefully, until we can get this part to be the same as this part down here. All right, I don't know how loose we're gonna have to make that, but as you can see with the wrench back there, it's the wrench that comes with it, 36 millimeter. We loosened it a little bit. Might have to loosen it more, but let's try starting there. So we're gonna try starting there. Most is not gonna hang from this, even though it is magnetic. A few taps, let's see where we're at. So that was pretty light hammering. Let's just check where we are. Still in the same spot, so let's try to make it a tiny bit looser. That moved a lot, maybe too much. We'll find out. This is the same 0.25. This is saying 0.3. 0.3. I want to show you how far off the actual measurement is. See, we're measuring almost a degree off, it looks like. So let's see where it moves when we tighten it. See, now we're at 0.2 instead of 0.25. So what we may have to do is undercorrect it to 0.25, into 0.3. Just 0.3. So you can see it's going back and forth between 0.25 and 0.3, which makes the exact measurement here a little tricky. Another way of doing it is just be able to set a reference. So now we're at 0. We can see how much different we are from this. 0.05. The limit we can really get here is probably somewhere around 0.05. So we're going to call that as good as we can really get with this method. On to the next method. Now for the next method, you're going to need some different parts. If you saw in my other mill video, which I'll put a link in the description to, we talk about run out on the stock chuck versus a really high-end chuck versus collets. So collets are always going to be best for holding your tools. The problem is you need a different collet for every diameter tool. So this is a 12 millimeter collet. I'll give a link in the description. Let me show you. It's an R8 collet. Is the type of collet, which is the shape that goes into the machine, and then the 12 millimeter diameter, which is the diameter of the tool it's going to be held. You can see there's a key in it, and then there's threads, so it gets pulled up into the machine, and as this tapers, it tightens the collet around the tool. And these are extremely accurate, and they also give you the most working space between the bed and the rotating part, the mill. So we put this in, feel for the key, and then tighten to pull it up. Before we pull it all the way up, we want to put a tool in that we kind of trust. So this is a Chicago Latrobe drill bit. These are extremely nice drill bits. This happens to be 12 millimeter, which is going to match this collet. I do try to use diameters that are on the slightly, let's say, larger side than like 3 or 4 millimeter, which in my opinion are more likely to get a bend in them over time. So I want to trust something more that's around this 12 millimeter diameter, or even more. So let's put this in. Pull the collet to tighten it. This tool in here to hold, and then we can tighten. And then what I'm going to do, I'm going to take one of these speed squares, which are fairly accurate right angle, got a nice flat spot right here to put on the mill. So what we're going to do is we're going to see how much of the tool lies flat against here. So you can see here is, zoom in, down here, they're not touching. This looks like it's more than it is because the rotation, but you can see they're not touching here. They're starting to touch here. We're touching up there. So there is an angle as measured by this device. Let's measure on the other side just to confirm. On the other side, it should touch the bottom first. We are touching here, it looks like. And then as we go up, it actually doesn't look too bad. So it looks like we're about maybe as straight as we can get from this method, since one side looks a little off and this side looks, the gap at the top is, it's really hard for me to even show it to you. It does exist, but I'm having a really hard time seeing it with the camera. It's basically non-existent. So with these methods, this is probably about as accurate as you can get. And whether or not that's accurate enough, it depends on the accuracy that you're trying to machine. Now let me show you the method that I use to get these aligned. That's much more accurate, and you can actually align not just in one direction, but you can actually align in both directions, although it's a bit harder to correct the forward to backward. All right, so here you're going to see SST is stupid simple tool. And as you can see, the 6-inch, 4.5-inch, 3 inches, you can put these two dial indicators, these distances apart, or any mix match thereof, to get the relative distance. This is a 1/2-inch shank, so we put it in a 1/2-inch collet. And then when this goes down, depending on the rotation, it's going to measure when these two sides hit. And this is a precision piece. Now, we do have to calibrate these, and the two dial gauges are not identical. This one, you can see, you can rotate it to adjust it. So we can set that these are going to be measuring the same amount when they're pressed in the same amount. You could also shim them as you put them in. The thing I don't like about shimming is that it's going to change every time I move them around anyway, so might as well just calibrate them. Now to calibrate them, you do need some extra pieces as well. I wish this company just built a calibration block for this. It would make it much easier, but I'll show you how I've been doing it. So this is a setup block that I use for my mill, and it is extremely accurately made. So we're in inches. Let me zero it. So let me show you when I'm measuring this. I use it a lot, and it's still, yeah. And this goes into your chuck, or in this case, we're gonna be using collets because they're the more accurate and give us better working distance. To use this tool, you do have to calibrate it. So you have to have a flat surface. Now, how do you know if your bed is flat? Well, it should be flat. The table should be flat, but in case you're wondering if it is or not, then something that's useful to have if you're doing this type of work anyway is to, invest in a straight edge. Here's the one we have here. So to use these, I just like to put them against the surface, and then I look down real close, not gonna be able to see it with the camera, see if I see any light coming through, or to basically feel if I can rock it back and forth at all, and try to get you real close here. Should be able to see that the straight edge is sitting extremely flat on the surface, so it's going to be certainly close enough for this type of calibration. So nice and flat as well. The reason that's nice is we can just kind of drop this down on our table here, and then
use it as a surface, put the tool flat against. At this point, what we want to do is hold it in place and then adjust the dials so that they read evenly. I always like to take more than one measurement, so there's different channels here, so let's move it to another channel and try to get it centered on the channel. And you want to find a measurement that's kind of as consistent as you can be. We're going back to this side. The other thing is, because it's kind of hard to get this centered on the blocks, we can put 2 blocks together, see if that helps out at all, get a consistent measurement. Another thing we could try doing is using the straight edge as a surface. It's going to be at 6 inches, somewhere around 1,000. It's going to be really hard with a setup like this to get this thing calibrated even to better than a 1,000th of an inch. Just for fun, let's gauge blocks on different sides, see if that makes a difference. Now they still look calibrated. Let's, for fun, flip our straight edge over. Let's see if that works the other direction as well. So we're kind of chasing our tail at this point, but you're going to see that the limitation of this type of calibration is probably around 1,000th of an inch. The imperfections in the table as well, at least for one of these mills, I think you're getting, at that point, you're really getting to the limits of the precision of this whole apparatus. This is going to be as precise as I know how to get it. So.
All right, now the problem with calibrating this thing is it's really challenging, even with straight edges and setup blocks. I'm never really able to get it calibrated better than 1 to 2,000ths of an inch. Luckily, despite what this says, the calibration really doesn't matter. And that's because this thing is on an axis that spins, which means we can just spin it around, take another set of measurements, find the difference, and then use that to figure out what's flat and what's not. So what I recommend doing with this thing, and I actually did email this company. I email a lot of companies and they virtually almost never email me back, even when I'm offering to buy things from them. We'll see if SST actually emails me back. I did say that, if they want to build something that makes this easier to calibrate, something you can kind of fit in kind of perfectly and then push in, across these different setups, the same amount. They can actually calibrate these things. That would be awesome. You can try to calibrate them yourselves, and if you can do better than a 1,000th of an inch, then that's awesome. I don't think I can reliably do that. So instead, let me show you what I do. You do need a piece of paper or some way of taking notes. So we get this set up in the collet, just like normal. Tighten up on the collet, and you just want to come down and take your first measurements. Line up the bed. All right. So once we have this thing lined up where we want to go, what you want to do is just bring it down and bring it down enough that you feel comfortable with the measurement. I like to lock in the fine adjust. So get 30. Whoop. So we can get 40 on the right one. All right. Now we just got to write those numbers down. So we're going to say, I'll show you how I write it. So on the left side, it looks like we have 35, 36, 36 and a half. On the right side, we have 40. All right. Let's bring it back up. And we just spin it around. Now, obviously, you got to look on the back of it, see where you're going. You don't even have to get to the same measurements, but make your life a little easier if you do. Totally up to you. It doesn't really matter. All right, so let me show you what I did. So when we have it facing forward, this line demarcates the shaft that comes down. On the left, we were in 36.5, for the right, 40. Now we spin it around, this side goes to the right, so I set this one at 40 again, just to make it easy. And then you can see the left side went from being pushed in 36.5 to being pushed in 17. So it's not being pushed in nearly as much, meaning our right side is 19.5 higher. If the right side is higher, that means that we're tilted to the left. We need to tilt it back to the right. At the end of the day, the offset should be the same. So if I'm flipped around 36.5 here and 40 here, and we're flat and we flip it around, then this should be 40 and this should be 36.5. So again, you don't need to set the 40 on both sides when you got to do a little bit more thinking about it. For me, we'll keep that diagonal the same. So what we want to do is keep moving our top here to the right until the left and the right here dial reading are the same. All right, let's get going. So we want that 36.5 to be closer to a 17. So we're gonna lift this side up. Let's loosen. That's really close to 40 and 26.5, but we still have to tighten it, which is always, it tends to mess this up, but let's see where it goes. 40 and 26.5, right on after fighting with it for a while. All right, so let's flip it around and see where we're at. All right, so now we're spot on, 26.5. We have 44 diagonal, 26.5, 26.5. So you can see, even though these two are not synced, because the numbers are the same, regardless of which 180-degree rotation we're at with the tram, then we know we are in spec, and we didn't have to have a headache over synchronizing these things. So let's do it in the forward-backward now that we're all tight left to right. Actually, let's see how far off the indicator is, too, for this thing. It's about half a degree off, maybe. Let's say half a degree off. All right, so we'll get switched around to the short direction because we can't do the long direction for forward backward. All right, we have our tram reconfigured for a 3-inch separation. Let's get back in there. So 40 and 31, 32, I'd say. Flip it around. And since I had already put shims on these, it is checking out to be perfect. So this is front versus back. I remind myself it's the 3-inch side, so back, front. Originally back was 32, front was 40. Now back is 40, front's 32. Let's see here, it's right angle, yep. So, and just as a reminder, we did have to dial in some shims right here. To do that, these are just 12-inch feeler gauges. We can cut this off if we want. And we had to detach the bellows here from here, which keeps the chips from getting out of here, but we had to detach it so we can get down here and get these shims in. All right, so it looks like we could probably shim under the front of this, and then we would maintain our ability to rotate easily without the shim getting in the way. So what we're gonna do is loosen these, see if we can get a shim under here. So we're gonna clean out really well in here, loosen these up, and use the shim there to adjust the front to back. So we're gonna start off with the 10,000ths shim in there, just to see where that gives us, and go from there. So now we're all set. We are now ready to true up this piece, make sure that we are sliding left and right and keeping the same distance front to back. Basically, we're not sliding on an angle. We're definitely sliding left and right. All right, let's get that checked, and then we'll be all done. Finally, what we're gonna measure is basically how straight is this table running back and forth. So to do that, we're gonna use one of these, another dial gauge, and we just need to put this on a hard reference point. It's not gonna move, and have it run along the edge here as we move the table, see if the channels are moving left to right, side to side, what have you. So I'll start out just getting this thing mounted on the magnet. All right, so we're zeroed out. We're pretty far on this side of the table, so we're gonna move the table and see if we trend towards one direction or the other. All right, see, we made it to the other end, and we're still pretty close to zero. Each one of the gradations here is a half of a thousandth. At most, it's a half of a thousandth off. That's actually very impressive. All right, I hope you found this video useful, showing a couple of different ways to make sure that your mill is aligned across all the axes. If you guys got any other tips or know any other ways to get more precision out of aligning these things, please let me know. Throw it in the comments. I'd love to learn. I'm quite happy with it now. Do know that if you get one of these things, you can see that for a precision tool, we're off half a degree here. We have some shims in the system to get it all straight. Do know that if you get one of these, it's not going to be accurate unless you do these things first. So these are really must-dos if you want to do any type of precision or even approaching precision work with one of these Harbor Freight mini mills. Otherwise, it's nice, cheap, and does its job. Maybe if anyone wants to, I can talk about how I installed these DROs on there, but we can leave that for another time. Until next time.